Hi, everyone. My name is Tristan Ma, and I'm a solution architect here at Elastic. The topic I'll be covering today is how to leverage Elastic's machine learning in your logs, metrics, and traces to reduce your mean time to resolution. But before I start, I just want to start with this simple slide, which is how Elastic approaches machine learning, which is truly to operationalize and simplify data science. We understand that not everyone has giant data scientist teams that they can use to apply and create all these models to monitor your systems. So our goal is to try and democratize the benefits of machine learning in a way that doesn't require you to have a data science degree. So with that, let's jump over to today's presentation. So I'm here in Slack, and I've gotten an alert letting me know that I have a critical anomaly with a score of 92, indicating high response times in my advert service. And effectively, we just have a little label here letting me know I have high mean transaction duration for the advert service. Short way of saying what I just said in the description, and both these components are customizable. So if we go ahead and click on this link, it'll bring us over to our APM service page. And effectively, this just gives us a graphical representation of the flows of our application. And as you can see here, we have a couple different colors, or three actually, on the screen that aren't just for decoration. What they're actually powered by is our out-of-the-box machine learning job to monitor the service health of the various microservices we have instrumented with our Elastic APM. So majority of our services is in green, we have a couple in yellow, and then of course we have the advert service, which we got alerted on, letting us know there's an anomaly to explore. So let's go ahead and do that. As we click on this anomaly, as we see here as the screen slowly comes up, we see we have a few different anomalies coming out of the norm. So really quickly, just a quick overview of the page. The light blue shading here indicates the typical expected behavior. And this is based on our unsupervised anomaly detection, just learning the typical patterns of your systems. As you can also see, we've had a couple different spikes in terms of latency, but we didn't get alerted on them. The reason being, we've specifically defined the alert condition to only alert us via Slack on critical anomalies. And speaking of critical anomalies, let's go ahead and take a look at the one we got alerted on. So as you can see here, we have a severity score of 98. The detector kind of gives us some information on what it's detecting, and more importantly, it gives us typical behavior and the actual behavior, and more importantly, how far out of bounds that typically is. Now, as I mentioned, the score, I keep mentioning the severity score. So as part of our objective to operationalize data science, we don't want to always just tell you what is anomalous, right? As you can see, we've had anomalies throughout the system, but we've only been alerted on the critical one. And that's because we want to be able to give you just an inclination on how anomalous something is, so that way you can go ahead and determine your workflow, so that way you're not constantly getting pinged for these lower level anomalies, which may just be, typical every now and then a small latency spike, versus something that might actually be causing a problem. Now, as nice as this anomaly is, it just lets me know that I have high latency in my application, which is great. It's nice that I'm alerted before my customers are letting me know there's an issue, but it's not really helping me truly understand what may be causing the issue. What would be nicer is if I also knew if there are any other anomalies in our underlying infrastructure or in my logs. So to do that, we just jump over here to our Anomaly Explorer. And we come over here and just grab the groups. So what's really nice is we can go ahead and group our out-of-the-box machine learning jobs. So you can really just look at the ones that are relevant to you. And in this case, I want to look at the APM anomalies, any anomalies in my Kubernetes infrastructure, and also in my logs. So if I go ahead and inadvertently fix the time range on this one, we can see a few different anomalies, but what we're also seeing is our original anomaly, right? This is our high latency anomaly. But then what we're also seeing for the advert service is we're also seeing a higher than usual memory utilization in the underlying container that's running the advert service. And more importantly, what we also see in relation to that memory error is we're seeing a rare log message for our advert service indicating an out of memory error. Now, if we go ahead and expand this out of memory error, we can just see a few different things about it, but more importantly, we can see some examples And we can jump to those specific instances of where we're seeing the out-of-memory error should we want to take that path for an investigation. But as you can see very quickly, by having Elastic's machine learning embedded in your logs, underlying Kubernetes infrastructure, and your APM services, you're not only able to indicate when you're having high latency, but you're also able to quickly and automatically surface other problems throughout your system that may indicate what's affecting one service and allowing you to more tailor your investigation and thus your resolution in a more timely fashion. Now, some of you may be thinking, as nice as this all is, this is a demo environment and you clearly have everything set up. So I'm going to go ahead and kind of show you how easy it is to go ahead and get started with these 3 jobs. So I'm going to quickly switch here to a space where I have the correct permissions. Now, to go ahead and start with the first set of anomaly detection we started with, i.e. our service map, we'll come back and navigate over here to our service map. And as you can see, no colors. Very easy. All you have to do is come up here to our anomaly detection. Go ahead and click Create Job. Select which environment you want to apply it to. In this case, I want to apply it to my prod environment. Go ahead and create the job. And that's it. That's all you have to do to get started. Now, if we also want the log category job, easy. Come over here to Categories. Come here to ML Setup. Let us know when you want to start the time, and time is typically indefinite. Go ahead and select what data set you want. And again, click Create Job. And then finally, for the memory utilization for the underlying Kubernetes infrastructure, again, very similar to our APM setup, come up here to anomaly detection. And here you can enable either the Kubernetes pod, or if you're running host, we can also run on host as well. I hope this was helpful for you to see how meaningful it is to have Elastic machine learning across your logs, metrics, and traces to quickly resolve issues, and more importantly, how easy it is to get started. Thank you very much.